In addition to systems of linear equations, we can also have systems of linear inequalities. And at this point, all we're going to do with these systems is graph their solutions. So here's a typical example of a system of linear inequalities. Y is less than or equal to 3x minus 1, and 2x minus 3y is greater than 6. Again, I'm going to label these A and B, so we can keep track of what we're doing. Just like the linear equations, we'll graph each one separately first. Let's quick remember what we do when we're graphing a linear inequality. We get 2 points as if we were graphing the line first. So this is in slope-intercept form. The intercept is -1. The slope is +3, so that means we go right 1, up 3. Second, we decide whether the line should be dashed or solid. In this case, because this is less than or equal to, the line should be solid. And now we decide which part to shade. I'm going to decide by thinking about the y-axis. That is where x equals 0. If I plug in x equals 0, I get y is less than or equal to -1. Where on the y-axis is y less than or equal to -1? Y down here, of course. So this is the part of the graph that we'll want to shade for the first inequality. Okay, B is next. This is not in slope-intercept form, so we're going to find the x and y-intercepts. And now again, we're thinking of the equation. First we'll let x equal 0. 2 times 0, that's just 0. We have -3y equals 6. Divide both sides by -3, and we get y equals -2. So this will be the point 0, comma, -2. Now we'll try the same thing with y equals 0. Again, 3 times 0 is 0, so this is just 2x equals 6. Divide both sides by 2, and we'll get x is 3. So this is 3 comma 0. Okay. X is 0, y is -2. That's here. X is 3, y is 0. That's here. There's my 2 points. Do I want a solid line or a dashed line? This is strictly greater than, not greater than or equal to. So the points right on the line we don't want to have in our shaded region, so we use a dashed line. Alright, now we just need to decide whether to shade above or below the line. Again, I'm going to think of y equals 0 here, because then I don't need to think about this negative number. So I'm going to be thinking about the x-axis. I'll get 2x is greater than 6. So that's where x is greater than 3. X is greater than 3 over here. So I want to shade this side of the second line. Okay, now we're almost finished. We've graphed separately our 2 inequalities. But we're looking for the points that satisfy both inequalities at the same time. Points over here don't satisfy either one. Points up here satisfy A and not B. Points down here satisfy B and not A. What we're looking for is this overlap region. This region is the solution to the system of inequalities. I'm going to give you one of these to try. Graph the solution to the system. X minus 4y is less than 4, and y is greater than or equal to negative 3/4 x plus 2. Pause the video and try this now. Okay, again, just so I can see what I'm going to do, I'm going to label these A and B. A is not in slope-intercept form. So to get my 2 points on the line, remember I'm thinking of x minus 4y equals 4. To get my 2 points on the line, I'll first let x equal 0. I'll get 0 minus 4y equals 4, so that's just negative 4y equals 4. Divide both sides by negative 4, and I get y equals negative 1. 0 comma negative 1 will be my first point. Now I'm going to try with y equals 0. I'll get x minus 4 times 0 equals 4. That's just x equals 4. So I'll have the point 4 comma 0. Alright, let's plot these points. 0, negative 1, 4, 0. Do I want a solid line or a dashed line? This is less than or equal, so I want a solid line. And now I need to decide which part to shade. Looking at this thing, I would probably choose to think about the x-axis, so to think about when y equals 0. But we could choose to look at the y-axis, and I'm just going to show that for the sake of demonstration. So I'm going to think x equals 0 here. So that'll give me negative 4y is less than or equal to 4. I'm going to divide both sides by negative 4. Negative 4y divided by negative 4, of course, is y. 4 divided by negative 4 is negative 1. And when I divide by a negative number, that reverses the inequality, right? 1 is less than 3, but negative 1 is greater than negative 3. Multiplying or dividing by a negative number reverses the inequality. So I'll get y is greater than or equal to negative 1. Where do I want to shade? The half of the graph that contains the top part of the y-axis. So I want to shade up here. B, the graph's going to be a little bit easier, right? Because B is in slope-intercept form. The y-intercept is positive 2. The slope is negative 3/4. That means I go over 1, 2, 3, 4. I go down 1, 2, 3. Do I want a solid line or a dashed line? This is greater than or equal to, so I want a solid line. We'll fill that in. Now we just need to decide where to shade. Here, definitely thinking about the y-axis is our right choice, because when we plug that in, we just get y is greater than or equal to 2. So again, we want the part that contains this top half of the y-axis. We want to shade this part here. The solution to the system, then, is where this shading and this shading overlap. So the solutions to the system all lie in this region.